Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be showing you the proof of the product rule. You probably know the product rule where you have you're multiplying two functions u of x and v of x, which you can also call uv. Of course, you know that u and v are both functions of x, right? And you just know whenever you have an issue like that, you just know the formula is u dv dx plus v du dx. Now the issue is, where does that come from? So that is what exactly this video is about, and it is from the idea of first. It is from the first principle. If you have not seen my series of videos on basic calculus, where I treated everything starting from functions down to applications of integration, you can check my the playlist. That is its own special playlist. There are up to 26 videos or so there, so please visit that. So I'm just picking this out of that because I know it's important for people to know how the product rule came about. Okay, so the idea is that you have a function y, which is a product of u of x and v of x, which you can simply call uv, right? And from first principle, the basic idea about first principle is that a little increase in the independent variable, and in this case, it can be u. We can see independent variables are u and v, as u and v that are deciding y. So a little increase in each of them is going to lead to a little change. Not, change can be increase or decrease. So it's safer to say a little change. So a little change delta u in u and a little change delta v in v will result to a little change delta y in y. And that is why y equals uv can now be the same as y plus delta y equals u plus delta u plus v plus delta v plus delta v. And then the next thing you just have to do is to expand, right? So you have u times v, uv, u times dv is u dv, then du times v, that's v du, and du times dv is du dv. All right. So the next thing now is to, at the end of the day, we are looking for dy dx, right? We are looking for dy dx for y equals uv. And so far, that's all we have. So the next thing is, since you're looking for dx, so at least y has got to go to the other side. And that's why you have dy now to be uv plus udv plus vdu plus dudv minus that y that you brought here. And then you remember that the y you started with is actually equal to uv, y is equal to uv. So then you simply replace y with uv. And once that is done, you quickly say that uv cancels minus uv. And then what you are left with is this. So you are left with udv plus vdu plus dudv. Okay. So at this point now, it looks like the coast is clear for you to divide by delta y. And don't forget, we treated limits, right? And we said, that limit, if without limit, we cannot do differentiation. So here you divide through by delta y, delta x, so that you have delta y, delta x, and then you have, for this now, you have u dv divided by delta x. So that's u delta v delta x plus v delta u delta x plus delta u delta x all over delta x, like that. So, and you know that for you to get the pure dy dx, right, from delta y delta x, you need to take the limit of delta y delta x as delta x approaches 0, okay? So that means you're taking the limit as delta x approaches 0 for this whole expression, u delta v delta x plus v delta u delta x plus delta u delta v divided by delta x, okay? Now, we already know from the rules of limit. Okay, it's part of the things that treated are the rules of limit in the series of basic calculus, right? So for the rule of limits, we already know that the limit of a sum is the sum of the limits. So if you want to find the limits of these three things added together, it is the same thing as finding their limits individually and summing it up. So the limit of a sum is the sum of the limits, okay? So that's why we can open this up and now say, okay, limit of delta x as limit as delta x approaches 0 for all this is the same thing as the limit of this plus the limit of this plus the limit of this. And since delta x is approaching 0 and u is not affected, that's why we bring u out here, and you have limit as delta x approaches 0 for delta v delta x, and v limit as delta x approaches 0 for delta u delta x plus limit as delta x approaches 0 for delta u delta x. There's nothing to bring out here, so we just leave it that way. So we are going good. Now, what happens here is that, I said from the beginning that a little change in U and V, that's delta U and delta V respectively. It's a little change. So imagine you multiplying a little change by a little change. It becomes even littler. If that's the correct word to use, it becomes even smaller, right? And because it becomes smaller, it's approaching zero. So that's why we just take this limit to be approaching zero, and that's why we have zero here. And for these other ones, we just have the whole thing purified, okay? So if you revisit the idea of first principle from this series of videos I made also, you'll see that here. So now, because of these limits now, delta U, delta V, delta X, delta V, delta X, and delta U, delta X now become this pure thing, the V dx and the U dx. And of course, because little multiplied by little becomes littler, and that basically goes to zero, we have this one to be zero. And then at the end of the day, finally you just have U dv dx plus V du dx. That's the simple proof for product rule. So from today, I mean, now you know the proof if you never knew before. And if you knew and you forgot, now you have been reminded. So to get this kind of refreshment, I mean, refreshing math stuff like this, make sure you're subscribed to this channel, hit on the bell button so you can always get alerts when new videos are released. Thanks for stopping by. See you in the next video.